The time, the order and effect, the most essential things that we deal with, we control and work with to turn a simple graphic into motion graphics. Now we know the Blender as a software is pretty much capable of delivering motion graphics or animation, but all this while in the previous versions of the Blender there was not really a dedicated tool for creating something procedural, non-destructive, something which can scale up and to be able to create something really complex. There was a tool which was required, and the geometry node is exactly that, is being developed and have been introduced in the recent years to take care of all the missing elements that were required for the procedural stuff. So be it scattering, motion graphics, animations, special effects, the more and more every year is being introduced in the node format. And this is going to be the future of the Blender. So today's chapter is going to be about creating simple motion graphics, how you can access all these three essential things, that how you can manipulate the time, the rhythm of the animation, the order in which an effect takes place, and the effect, which could be as simple as a simple jumping box, or it could be as complex as disintegration of an object. So time, order and effect, this is what we are going to break down today's chapter into, to be able to make it more simple and understandable for beginners to begin with. So this is Ram from CrossMind Studio. Welcome back to the chapter number 12 of Geometry Node Introduction series for the beginners. Let's roll in the intro. So the very first question is how and why the geometry node is useful for the motion graphics. So let me give you a visual example here. So this arrow here is a very simple object. So with the older tools, let's say if you're creating something with the animation timeline, what would you do? Let's say if we wanted to animate this from the left to right, you'll simply move this one into the X direction or Y direction, whichsoever, and then this is going to set a key for the animation. So this is pretty straightforward and easy to deal with. But what about if I needed to create another copy of this one? So you might would think, let's create another copy by pressing Shift D. That we can do, but then we'll have to tweak the animation again. Or if you're clever, you might be able to achieve that effect by bringing one empty object maybe, and then create a duplicate, parent this with this one, and then maybe try to hack this process. Yeah, you can do that. But the thing is, now imagine if we had hundreds of these. What would you do? Can you actually plan something more complex with it? Now you might would think maybe an array modifier will be able to take care of this. But if you have multiple instances, let's say in the array modifier, you still can't really access individual instances within it. Or maybe if you're dealing with the particles, then I mean there are options, but still it's really easy to hit a wall and not get the desired results. And it's not really as flexible as the geometry node. When you start working with the geometry nodes, you'll see how powerful it is. It will slowly start to grow on you. So let's start with something really simple and slowly work our way through the complex. So now the similar effect I'm going to make with the geometry node. Here I have the geometry node editor, and let's click on the new. So we were transforming this object in the X direction. So here I have an effect which is a simple transform. Now only thing I need is time. So scene time node is going to help you animate this. So this is basically simply going to insert the progressive frame number, that value. The progressive number is going to derive any of the parameters we link this with. But before that, we need to break these axes down into 3 floats. And now let's plug this into Y, X direction. Let me delete the keyframes that we previously made. So there is no animation now, and if I plug this here, we have an endless moving arrow, and this would last for as long as this timeline lasts here. So pretty easy, right? Now if you need to tweak the speed of the animation, simply bring the math node and multiply the speed by whichever number you would like. So now we have a slow moving arrow. Now we have slightly faster moving arrow. Now the fun part is, now everything we have here is in node format. We have the time in the node format, we have the order and effect, everything here in one simple node tree, and it's really easy to read, really easy to manage, and really easy to access and organize. Now as we were speaking about the complexity, what if you want to flip this animation now? You can simply bring a transform node here turn this into 180 direction, and the entire animation is flipped into opposite direction here now. Now, if we can combine both of these nodes, Control Shift right click and drag, or left click if you are using. That way we have this animation and this animation combined into one joint geometry node, and this will give us two arrows moving into multiple directions. Now you can transform this again 90 degree, combine these two, and now you have 4 arrows. Now what if we wanted hundreds of these? No, this is not the right way to do that. Let me just give you another example. Let's say if we have a simple mesh circle which is about this big and we have 32 vertices. So what we can do is create instances on points, and in the instances we can plug in our geometry, the arrows. Now we have 32 of these. You can make as many of these arrows as you want. Now let's align these with align Euler to vector. We need to change the rotation of these arrows into something more usable. So I think if we bring in the normal direction of this circle, this would be able to give us something which is moving inwards and outwards, something like this. Now what we want to do is move these arrows inwards and outwards in their own individual direction. Now you would think that we can transform this again, but the thing is this would transform everything. And keep in mind, transform node basically transforms everything. If you look at here, this says the geometry. It transforms the geometry, the entire geometry that's being created before this. If we need to access the instances, you need translate instances. Now this will give us the instances access. Now if we try to move these in the x direction, now each of these are going to move in their local direction because the local space is enabled here. So without much of an effort, we have a nice radial array of an object, and we can control the animation of it by bringing in combine XYZ, separating these axes, and plugging the scene time into x-axis. So we have a progressive animation, kind of like a ripple effect going on here. So with a fewer clicks, very minimum nodes, you have something which you would be struggling with if you were creating this with modifiers. Now here's another interesting example. If you bring a texture and instead of using a linear time here, let's make this into a 4D texture and use this value into the x direction. Now we have these arrows, and these are sort of moving varying speed because the texture is kind of organic texture. Now if we change the time value here, you'll see all of these arrows have their own unique position and animation. So the much more detailed the texture is, the more detail you will see here in the effect. You'll reduce this, the less detail you'll see here. And if you animate the time value here, you have this animation, which obviously we need to slow down by quite a number so that we can see something useful. And more about these things you can control, and there are so many nodes to help you with and achieve the desired results. Now when working with all of this, at the back of my mind there is no worry that at any point if something goes wrong, I might not be able to access all the previous work that I've done. So let's say if something changes in the node tree here, if I make any change, all of this is going to automatically update. And that is a big relief when you're really working in the professional environment. And there is no end to how complex, how further you can go into this. Now we were dealing with the one simple mesh circle. What if we bring a mesh line and instance on this mesh line, our original circle? So we have an array of circles. Now you can reduce the height and bring a random value and plug that into the scale. So you sort of have multiple circles of the different diameters. Now you can realize this geometry and plug this one into the original instancing, into the input of the instances where we have these arrows. And just like that, you have many more arrows and many more layers of the circles. And if you feel you need to change the texture, you can always press Shift F, Shift S and switch any node into something else. So very simple example, but something which we would be struggling with to create with the older methods in the Blender. And all of this is procedural, non-destructive, and really easy to manage and work with. Now, even though this would seem simple, the effect or whatever we have made here, a pretty typical example of the motion, the graphics that you see on the maybe everyday TV channels or the news channels or something, or maybe the audio visualizer. But the thing is, especially for the beginners, when you start thinking about these effects, it could be a bit difficult if you're just doing it for the first time or just beginning with the geometry nodes, like how to figure out these effects. So for that, it's really important to break it down into 3 different things: the time, the order, and effect. So if we look at this node tree here, so the first thing we have is the input geometry. That is the simple circles, the array that we made with the instances of the circles on line. So this is the input geometry, and then we have the instances, which are the arrows that we have made. So if you look at this graph, we have the input geometry. The effect in this case is the translate. Basically, we are moving these instances into their own axis. So that is the effect. And the order in which these arrows are moving, these are moving into X direction with varying speed, which is being driven by a texture. So this is the order, this is the effect, and the time here, the scene time, which is being multiplied by this much number. So pretty simple thing, and especially if you are beginning with the geometry nodes, it's really important to understand. And so we are going to create a few more examples in the same format for you to get comfortable with the basics of creating simple motion graphics in the geometry node. Let me just get rid of this and create a new node tree here. So first I would like to discuss the 3 essentials that we have been focusing on: the time. So if I bring the mesh line here and move this into maybe X direction, instances on points. Now for the instances, we have these arrows, and these could be facing maybe upwards or something. Let's slightly increase the gap. Animating in the Blender, you create keyframes, and if you're really comfortable with the Blender, you might be aware of, let's say, if you create a keyframe here, when you go to the node editor, the graph editor, you see the modifiers here, and these modifiers let you add a special behavior to the timeline graph of the motion that you have. You have generator, which generates a constant value, which is a progressive value. Then you have something like noise, if you're creating something with a shaky movement like the camera shake or something. Then you have stepped interpolation, which you can use for the stop motion or something, and you have a few more. So similarly, when we bring in the time input in the geometry nodes, there are a few more things you can do with it instead of using it as a flat number. So if I translate these instances into X direction, combine XYZ, translation, X direction. So what would happen is all of these are moving upwards, which is completely fine. Now this number, the progressive number, we can modify this, the output of this number, with the help of math nodes. Even in the shader editor, you can do so much with the math nodes. So similarly, if I bring a math function here, the very first thing, what we just did, we can increase or decrease the speed of animation. The second thing, which I would like to discuss here, is the snap. Now you can set an incremental number. So when the animation meets that threshold, the incremental number, only then the change will happen. So this is something like the stepped interpolation. Now our animation is constantly moving upwards. So let me disable the snap. And here there is another favorite node of mine, which is pretty useful for the animation in motion graphics, which is modulo. So modulo is going to repeat the animation, reach a certain number, and then come back to 0 again. So if I increase these, so if I increase this value, the speed, you see we have something sort of a loop. Instead of modulo, you can also use ping pong, and there are many more possibilities here. Like you can use sine wave, or you can use the power node to sort of ease in or ease out the animation. So now let's bring a Musgrave texture and use this, something like this. So the time value here is being multiplied with the texture, influenced with the texture node here, whatever is the outcome. Sorry, we have multiple multiply nodes. So we have the outcome, and then we have the modulo, which is basically creating a loop. And if you enable the snap, you have something sort of a visualizer, like maybe glowing signages or the traffic lights, or all those neon effects that you see on the boards, LEDs, the display panels. So these are pretty typical examples in the motion graphics, and like what you see here on the MTV. By combining such simple graphics, you can make something of a bigger scene, introduce these small effects, and you have something for your client. The time here, instead of a flat number, we are modifying the time with multiple of these math nodes. So pretty interesting way of using time. And the thing is, you don't really have to create any keyframes, and this animation can go on for as long as your timeline lasts. So a nice procedural way of controlling time in the geometry nodes. Now let's talk about the order. So in geometry node, especially known for creating something for a large number of objects, if you're scattering something in thousands or hundreds of objects, if you're creating arrays of maybe hundreds of objects. So how do you address all those instances? How do you define an order is something to talk about. So if you have a simple node graph, and if you maybe transform this one, well, you don't really need to address this object, but automatically this node network knows that we are talking about this object. But what if we have a mesh line, and on this mesh line we create instances? Now we have 10 of these cans of soda or juice, whatever you want to call it. Now let's say if I wanted a specific of these cans to have some effect, how would you address it? So for that, let me give you a real world example. So how do you address something in the crowd? So let's say if 10 people are standing in the row, you can either call them by their attribute. You could say the guy in the green t-shirt. Now the green could be an attribute, the guy in the pink t-shirt or something, or the girl standing on the extreme right, or the second last one. Or you could simply say, or you could use other attributes like the taller one, or the shorter one. Similarly, in the geometry nodes, you have multiple ways to address or to select things. And now for this very subject, the selection, I have two really useful channels to suggest you, and they have really great explanation of selection. So one of these channel is called Open Source. The links are in the description, and they have discussed in the full length about the selection on their channel. And the other is by Johnny Matthew, and these are really great examples, and you can go in depth and understand how you can select in the geometry nodes. But let me give you a few basic examples. So if I translate these instances by this number, let's say, but right now this node doesn't know which one to translate upwards, so it's moving everything. So the most basic way to define a selection is by index numbers. So the mesh line which we have here, every point or every geometry that we create in 3D, all the vertices, all the faces are carrying index data, so that we can access with the index number. So now if I compare this, I can change the value. So let's say any index which is greater than number 2, 3, or 4, or 5, or 6, 7, 8, 9, only that index, only the object which are carrying index number which are greater than 3 are going to move upwards. So, or you could say, let's say index number 5, and then you could increase this range around it. Now this is based on the index number. You can do many more things like less than, greater than, or use the Boolean math node. So let's say if you want to invert the selection, you could simply do not, and the selection is not going to select these index numbers and do the opposite. So this is based on the simple index numbers. Now what if you had something more complex? Now let's say a mesh line on a mesh line creates a grid. So if we create a grid like this, now this would be more complex to address because we have the depth in the crowd, we have the rows, columns, and all that. So in this case, you can use attributes, you can use textures, and or you can do a more complex math to select the columns and rows. Like I said, the links in the description are going to help you, but the most basic way would be, let's say if I bring a wave texture and plug that into the selection. Now with the help of map range, I can define the which part of the wave. Here I'm basically changing the texture, the range of the texture, and that is reflecting in the selection here. And the other thing is, now there's a difference in using the selection or directly plugging this into the translation here itself. The selection is the Boolean number, so it could be either true or false. So these cans can either go up or stick to their default position. But the thing is, if you plug this into the float inputs, let's say if I plug this one into the Z direction here. So what this is doing is, this texture is deriving the position itself. So all of these cans are sort of picking up their location based on this texture here. So there is no question of which can is selected, which can is not selected. But you're sort of getting an illusion that, but instead all of these cans are moving, but based on this one. But you can clamp these values, and that somehow gives you an illusion that only the cans which are in the center or based on this texture are moving. So this difference is really important to understand, that not all the time you need to define the order based on the selection. You can always plug the textures or the inputs directly in the input which you want to derive. You just have to check the compatibility and take hints from the colors here. So this is based on the texture. Now if I have Musgrave texture, I can plug that one here like this, change the scale of texture, exactly what we did in the chapter number 7 or 8 or something when we were creating displacements, and then you can animate these. So pretty simple animation. So we know how to select with the index, we know how to select with the a texture. This is much more of a random selection or random order. Now what more we can do is take hint from the other attributes. If you have custom attribute, let's say if there is a vertex color or something, that you can access by plugging that into here. And then if you see in the chapter number 11, you might be aware of using the attributes. And the other way is using the position. So let's say if this was a crowd, so I could call the row on the extreme right or the people at the back. So I can address in the similar way by using the position data here. So if I use the separate XYZ, so let's say if I wanted to select only this last row here. So in the X axis, this way, the last row. So I could just separate the XYZ here and use that as a selection. And then I could simply compare this and set the range where it meets my requirement. Similarly, if I wanted to select these two, or you could simply go to the equal, you can increase the range and select the multiple of these rows or columns or whatever. And similarly, you can select other axes as well. Y, yeah, this one. So now we are selecting in the Y axis. Now if you take a hint from this gizmo here, you can see we are operating in the Y axis. So that's how you can address based on the textures, based on the position data, based on the normal data, based on any of the attributes which are available in the input, with the input format, in the input nodes, or if you have any custom attributes. So you can use all of that and make a selection. And also check the links in the descriptions, really important stuff to really make the most out of the selection. And then the last thing which I would like to discuss here, the effect. So the effects could be as simple as a simple transformation, what we have been doing, the simple translate instances, and then you can Musgrave texture, combine XYZ, plug this into the Z direction, do all sort of things and make simple animations. Or this could be as simple as this, or it could be as complex as disintegration effect, or you must have seen some crazy examples on the Twitter. People are coming up with all sort of things. Even the developers of the geometry nodes are surprised what all people are putting up on the internet. So you can even create some really complex particle effects, and So the effects are really could be one simple node like a delete geometry node, or it could be movement, rotation, like anything. It could be stack of multiple nodes. So that actually takes time, that takes some thought to come up with something complex and visually appealing. There's no list of effects here. Like if you look at the geometry nodes, so we have multiple nodes. Some of these like delete geometry node or the translation, this and that. So by itself, these nodes are not going to do much. These are going to produce a really basic effect, like just by deleting polygons or moving things. But you have to come up with something on your own, like the arrangement with the help of the texture, the order and the animation, the rhythm. You have to combine all of that and then create a stack of these nodes and try to break your geometry into a way that you have to create a visual treatment for it. And that's what we are going to do in a moment. We are going to create a few very basic examples of how you can combine all of these three things and create some simple effects. So so if you've seen the previous chapters when we were discussing about the proximity, the raycast, all those were effects that we had made. You can create something really nice and interesting by combining multiple nodes. And so let me give you a simple example of effect. Let's create a simple another node network, and we are going to create few very basic animations and simple effects with the help of mesh line again and the instances on points. And now we can simply create a rotate instances based on the number of index. Combine XYZ here, and now based on the index number, we are using the number, the value, and putting that into the Y here. With the help of math node, you can change the intensity of this. Or you could also bring map range like this. Now you can animate these values. Set a key here, set one key here, animate these values. Maybe turn it other way, set these keys. So you have simple twisting animation here. Now you can refine this, create something more acceptable, or you could simply, or if you don't really have access to the index numbers, you can simply create a gradient texture and plug that into the rotation. That is also going to work. Let's try something diagonal gradient or something, map range, and you have sort of a similar effect. So a gradient value of something like maybe a darker to brighter is affecting the rotation of these instances, but the result is quite similar to the index number. So there is always more than one way to achieve something similar. You just have to think a little. A pretty simple effect here. So let me give you one more interesting example how you can detail out your animation. Let's bring one curved circle and make a donut. Curved circle, solid. So if I take this circle, where is it? And try curve to mesh, and introduce the same circle in the profile curve, reduce the radius or something, and we have a donut. Now if I transform this, the profile curve in the Z direction, so what will happen is, let me show you with the lower resolution. So this is sort of moving from inwards to outwards. Combine XYZ, plug in the scene time into the Z, bring the max node to slow down the animation, and you have this animation. Now we can transform this something like this. So let me just clear out the mess that we have made here. Let's get rid of these. Let's keep the can and get rid of the rest of the things. So we have this simple animation, and on top of this, what we can do is instances on points. Let me just first plug this into instances, align Euler to vectors, and plug the normals in the vector direction. Now scale these, let's scale these instances down. Let's slow down this animation, 0.02, And let's try to reduce the resolution of the circle. So you have pretty simple animation here. Plug the gradient, try gradient texture in the scale, maybe something of this sort of formation. And with the math node, you can tone this down a bit. Or you could also do the map range. There you go. You have something which you can tweak further and use it for your product commercial or something. Now you can maybe mix some of these cans with the fruits or the ingredients that are being used in the juice or soda, whatever this is, and maybe detail out your scene effect, whatever. So with just a simple thought in the construction of the donut and the animation, you have this nice array animation going on. So you can keep on tweaking things and maybe try more rotation, or I mean the possibilities are endless. Example which you might like. Effect. Now, so we have this original geometry here. Let's get rid of this node network. This time we are going to use the Boolean effect, mesh Boolean, and on top of this we are going to bring one volume cube. So this volume cube is going to help us create something which we can use for the Boolean, like this. And then let's bring the scene time. Sorry, we have this order in which this effect is going to take place. And let's bring the scene time, plug that into the 4D, because we get the time in the 4D textures. And then in the math node, multiply this with 0.02 or something. So we have a moving texture now, which we can convert to volume to mesh, maybe use something of a higher resolution, set shade smooth, and let's plug this into the mesh Boolean and hope this doesn't crash. There you go. There we have it. I think this is a pretty interesting effect. Let's scale this down a bit. If you'd like, you can map range this effect, the texture, and you have a sort of a formation of an object. Now you can detail this out, dimension to the texture, do all sort of things. Or if you want, you can set material on this volume object, set this to mango or something, whichever juice you are putting into this can, coffee, juice. Even this can doesn't know what juice this is. See, so pretty simple effect here, and something you can use to create the formation of objects. You can animate these values so that this slowly emerges and creates a full can. I'm going to give you one last example before we jump on to the final assignment and create this construction of the coffee house. So this example is for those who are maybe creating animations for the product designs. They have sometimes you have a SketchUp model or something which you want to create exploded view for, and this is a really good example for using maybe position based input or a gradient based input or something. So let's say if let's bring a plane, and on this plane we are going to create a geometry node network. So let's drag this collection here. So this collection, basically we have all the data from this collection here. Now the separate children, so that all these elements are separate now. Use the relative, match it with the scene. If I translate these instances, anything within the collection is basically treated as instances. So translate instances is going to help you with that. So let's say if I bring combine XYZ, and we basically want to explode this model, move these parts apart, and then all these come together and assemble again. So these axes, which are basically X, I think this is X axis. So in the X axis we are I think this is Z axis. So according to the geometry node, this is Z axis. Something strange going on here. I think I might have some messed up coordinates or something. So in the z-axis, we want these models to move parallelly and come back together. So let's bring a gradient texture. Let's try linear texture first. Now when I disconnect this or connect this, you can see there is a slight change in the position. It's slightly moving outwards. Let's try to exaggerate this. Now all these parts are coming apart, moving away from each other. Basically, we are adding into their existing position with the help of this gradient texture. Now you can use position based input. You can try different textures. Maybe if I bring a Musgrave texture here and plug that into this, then I have these parts moving apart in the random random order. So instead, let's use something more useful, which is this. Now the interesting part about this is, with the help of map range, what I can do is control the start and end of this animation. Let me bring the map range again. So let me just increase the distance first, and now with the help of minimum range, I can basically put these parts together like this. So we are basically tweaking the texture, which we can't really visualize at this moment, but then in the next version of the Blender, you will get a viewer node which lets you visualize the gradients and the colors and all that. So you might be able to see it in the next version. So very simple thing, really simple trick. With the help of just these few things, you can simply drag one number and create this animation. If you want, you can actually set a keyframe here. And there you go. You have an animation like this. So just another example I wanted to add into today's session, because I thought this would be really useful for some of you who are actually using geometry nodes or Blender to expand their presentation skills or something. Now that we have created a few 3 or 4 set of effects, a very simple treatment, but even the simple treatments, such simple effects are really difficult to make with the modifiers sometimes, or with the manual animation. So with the help of just a few nodes, you can achieve something complex like this, and this is really easy to manage. That is the most important thing, that when you're working in a project or deadline, you want something which is easy to manage, which is easy to iterate and explore and work with. So that's why the non-destructive workflow in the geometry node is going to help you with it. Play with the different parameters of the objects. Just try to think of the construction of the base, think of the time, what kind of rhythm or motion you want to bring into that animation, and then try to slowly the look of the visual by stacking effects, stacking some multiple nodes, and create some visual treatment for your whatever you have. So all of these, when all of these come together, you'll see some nice piece of motion graphic in front of you, and that is what exactly we are going to do now. So all these rough practices, we are going to use all of these and make this construction animation that you've seen in the trailer. And exactly the same thing what we did today, what we did in this chapter, we are going to apply all of that into this one, and you'll see something which is more finished and interesting to look at, and could be used for presenting different kind of ideas. So maybe if you are into UI, UX, or even in the motion graphics, or you're trying product animations or something, you can use these kind of effects. So let's jump to the next chapter. And if you have stumbled upon this chapter randomly, please go back and watch the previous chapters in the right order for all of this to make sense. The files are on the Gumroad, the links are in the description. So I'll see you guys in the next chapter. Let's jump to this video right here, and let's start creating this nice construction animation. This coffee house emerges from nowhere, and yeah, so I'll see you guys right here in this video. Bye bye.